Hi there, this is Mr. Cardoso again with our next lesson, lesson 4 on Intro to Objects. And last time we created this instance method for our fraction class to make it more useful, to give it something that it can do. So like we said, the instance methods, what the objects can do, they're verbs to the fields that are like nouns, defining what the object is. We got cut off there at the end, so I didn't get to fully explain this example. So here is an instance method called times. So what its purpose is it's going to multiply two fractions and return the new one as a new fraction. So this is the return type. If you remember from before, this is what it's returning. You recall, as I was saying, if I'm multiplying two fractions, for example, 1 over 2 times 3 over 4, the result is 3. I go 1 times 3 is 3, and 2 times 4 is 8. The result is a fraction. So that's why my return type is a fraction over here. It should match whatever your result is going to be. If my result wasn't going to be a fraction, maybe it was going to be a decimal or something like that, I might put this as a double. If it was going to be a string, then I would put this as a string. But in this case, the answer is actually a fraction. Now, this is the name of the method, times. And then here we've got the parameters. So what do we need to be able to multiply? So you would think to be able to multiply two fractions, we need two fractions. And you're right, we do. But we already have one. The fraction that is calling this method is what we call the implicit fraction. In other words, this fraction. And again, this is the keyword. And so we call the other fraction, the explicit one, the explicit object, we call it other. Now, other is just a variable name. Notice it's not in bright blue. It's just black letters. It's just a convenient variable name. You can call it whatever you want. You could call it F1, for example, or F for fraction. But in this case, we call it other because it works with this and other. This, however, is a keyword, and it represents the current implicit fraction. So let's walk through how this actually works. So from our fraction calculator here, okay, so you notice we created two fractions, 1 over 2 and 3 over 4, for F1 and F2. And here we called F1 dot times F2. In fact, I'm just going to comment out this line for now. And really, traditionally how we would probably call this is like that. And just like you were calling, for example, if you wanted to call math.pow, right? If you remember, math.pow gives something to the exponent of something else. So for example, 2 to the power of 3 should return 8.0 because math.pow returns a double. So we should store this in a double variable. So for example, math double, let's call it results, equals math.pow to the power of 3. You should take 8.0 and plop it into result, and then if we want, we can print result, for example, like down here in your system.out.println, or you could put this directly here, right? So because this returns something, you want to put it into a variable of that same type of whatever this is returning. And so in this case, math.pow is returning double. We put it into a double variable. In the same way, what is this returning? What is the times method returning? So let's go to the times, and we see the times is returning fraction. So then we can store this in another fraction. So let's say, for example, let's call this prod, short for product, because we're multiplying two fractions, so we're finding the product of two fractions, F1 and F2. Okay, so this is the fraction that we have sort of declared here, called prod. Now I'm going to walk you through that on this side, step by step. Really, notice that we haven't used the new keyword here. Like we've used new keyword for F1 and F2, but we didn't use the new keyword for product. So if you remember from before, what that means is that prod is going to point to null currently. because we never use the new keyword. So prod is not actually pointing to one of these boxes. Now, let's go through the right-hand side. We always learn, with assignment, this is assignment, just like this, and just like these two. We always learn to do the right-hand side of assignment first. So let's take a look at the right-hand side here. f1.times f2. So f1 we have already declared, so let's create little boxes for f1. So f1 is pointing at, and I'm just going to skip the boxes for now, and I'm going to go 1 and 2. And f2 is pointing at a fraction with 3 and 4 as its fields. Now, so f1, when we go f1.times, and this is what we mean by an instance method. Again, there's no keyword static here, so this is an instance method, going back to the fraction class. And that means that an instance has to call it. f1 is an instance of the fraction class. So that's good. So I go f1.times, which is the name of the method, and then it takes another fraction. So that's what goes in the brackets, f2. Now, when this gets called, so this is called correctly, f1 gets mapped into this. So now in the other program, fraction.java, right, it doesn't know anything about f1 and f2. There's no such thing. They don't exist here, right? But they do get mapped into things. So f1 gets mapped into this. So this will point to f1. And why does f1 become this? Because it's the instance that calls the method. It's the one before the dot that calls the method. So f1 becomes this in this other class. And what do you think f2 becomes? Well, f2 becomes other because it's in the brackets, right? So f2 gets mapped over, just like in previously you learned with methods, it gets mapped over into the brackets. So this is other. F2 gets mapped to other. Right? So now we've got various handles to the same thing in memory. This and f1 are pointing at the same fraction, and f2 and other are pointing at the same fraction. But in this class, fraction calculator, only f1 and f2 can be used to access those fractions. And in this class, in the fraction class, only this and other can be used to access those fractions. Those are the only handles we have. So if I tried to use f1 in here, I would get an error because it has no idea what f1 is, right? So I'd have to use this and other. So now, that being said, that gets mapped over. So now we create this new one in here in the fraction class. Okay, so now we create this fraction. So this is all in my memory, right? So I create this fraction called products, not to be confused with prod that we have in this class. Okay, that's a completely different variable. So I create this fraction called product. This time I actually create the fraction because I use the new keyword. So because I use the new keyword, I actually create the fraction. But these boxes are currently empty for the numerator and denominator. I don't assign the values just yet. Now in this line, line 26, we do assign values. So we go this.new times other.new. So this.new is 1. Other.new is 3. So that we go 1 times 3, and we put that into product.new, which is here. So that gets a 3. Okay, and then the second one, we go this.den, which is 2, times other.den, which is 4. 2 times 4 is 8. And it takes that 8, and it puts it into product.den, which is this, product.den, and it puts us in here at 8. And so now that fraction has been created, and we are returning it. So where does it get returned to, that 3 over 8? So that goes back over here, and this gets replaced just like any other method that you've learned before. This gets replaced with whatever it was returning. So in this case, this product. But again, all it does is it returns the object itself, not the label for the object. Consider these to be like the labels, prod and product and F1 and F2 and this and other. So this gets returned, this object itself, 3 over 8, and we put it into this, this label. So now, instead of pointing at null, this prod now points over here. So again, in this class, we don't even know anything about product, but prod now points at what was formerly the product from the other class. I hope that makes sense of how we walk through that example. Now, of course, we could do another example, or we could just change this from F2 to F1. If I were to change that, then all that would do was change. Now we know multiplying two fractions are the same. Whether you go A times B or B times A, you get the same result when you're multiplying fractions. So all that would do in this case, it wouldn't change the answer. F2 would become this, and F1 here would become other. And you would still get the same answer because multiplication works that way. But for example, if you were doing division or subtraction or something like that, then yes, the order would matter. Okay, because one would be, this one minus the other one and so on. So I hope that example makes sense. I will do another example shortly, another instance method, and also talk about pass by value versus pass by reference. Thanks very much.